this lesson, we will look at one final operation we can do with sets called the Cartesian product. The Cartesian product is interesting in that it is somehow related to cardinality and multiplication. Suppose you walk into Starbucks and you want to order something, but you're a bit unsure as to what you want. You know you want either a tall or a grande. That's a small or a medium for you Tim Hortons fans out there. You've also narrowed it down to a mocha, hot chocolate, or pumpkin spice latte. We want to determine how many different drink choices we can make. Well, we could get a tall pumpkin spice latte, a tall hot chocolate, or a tall mocha. If we're feeling particularly white girl, we could go for the grande pumpkin spice latte. Or we have the final two choices of grande hot chocolate and grande mocha. So there are 6 different possibilities for this order. On this slide, we're going to summarize what we wrote down on the last slide, plus create some ordered pairs. So here's the list of what we were able to order. Let's just kind of condense this list a little bit using some short forms. So for tall PSL, we could write this as T. That's going to stand for the size of our drink, and PSL will be the drink order. So converting all the rest, we have T, and maybe we can use HC for hot chocolate, and then T and M for mocha. So we can use capital G for grande, and then PSL for our pumpkin spice latte. Again, HC for hot chocolate, and M for mocha. So we have 6 possible, what we call ordered pairs. Creating ordered pairs like we did on the last slide is an operation that we call the Cartesian product of sets. This operation creates ordered pairs, A, B, where little a is an element of set A, and little b is an element of set B. So in the Starbucks example we just worked through, we had capital A, that could represent the size of our drink, being either tall or grande, and set B, that could represent our drink order, pumpkin spice latte, hot chocolate, or mocha. And the Cartesian product, A cross B, is the set of all ordered pairs that we get from ordering in this particular way. So here's the full list of the 6 possible ordered pairs that we can make. Let's take a look at a few more examples. Let's try to find all ordered pairs of the sets A and B. Remember that we can write our Cartesian product as A cross B, and because it's a set, we're going to use our curly brackets. And we want the set of all ordered pairs. So maybe let's begin with the element 2 that's in set A. We could match that up with the element 3 from set B. And then we could match element 2 up with element 5. And finally, element 2 with element 7. These aren't all of the possibilities. We haven't used element 8 from set A yet. So we're going to get 3 more ordered pairs, 8, 3, 8, 5, and 8, 7. So we're going to have 6 ordered pairs all together. Out of curiosity, do you notice anything about the size of set A, the size of set B, and the size of the Cartesian product? Take a moment to pause the video and find the Cartesian products A cross B and B cross A. In this case, since A and B share the element 2, it might be helpful to see A and B as sets. A contains the elements 1 and 2, B contains the elements 2 and 7. A cross B is going to consist of all of the ordered pairs where I start with something in set A and I end with something in set B. So 1, 2 is a possibility, 1, 7 is a possibility. The element 2 from set A matched up with the element 2 from set B is a possibility. And then finally 2 and 7. B cross A is going to look a little bit different because now I have to start with an element that's in set B and end with an element in set A. So here 2, 1 is a possibility, then 2, 2, 7, 1, and 7, 2. Do you notice anything similar about A cross B and B cross A? Well, it turns out that the cardinality of the sets A cross B and B cross A are always the same. Now, as sets, they're different, but the size of the sets are always going to be consistent. In fact, if we happen to know the cardinality of the individual sets, capital A and capital B, then it's easy to calculate the cardinality of the Cartesian product. It's the cardinality of A times the cardinality of B. Let's work through one final example. Here, our universal set U is going to be the set of all letters of the English alphabet. The set A is going to consist of the first 6 letters of the English alphabet, and our set B is going to be all of the vowels. Let's try to determine the union of A and B, as well as the intersection of A and B. Recall that the union of A and B is all of the elements of A added together with all of the elements of B. So let's go ahead and list the first 6 letters of the English alphabet. These are all of the elements in A. And then we're going to add to that all of the vowels that aren't already present. So A, E, I, O, and U. Of course, the order doesn't matter, so if you had this list written in a different way, that's totally okay. Now, the intersection of A and B is going to be all of the elements that A and B share. Since B is the set of all vowels, the only vowels inside of set A are A and E. Next up, we're going to try to determine a relative complement. In this case, we want all of the elements that are in A, but not in B. So that's going to include all of the consonants that are in A. That's B, C, D, and F. What about the absolute complement of B? In this case, it might be easier to write it using words. The absolute complement of B should be all of the consonants of the English alphabet. The cardinality of A cross A should be equal to the cardinality of A times the cardinality of A. And the cardinality of A is 6. So we should get 6 times 6. That means that if we go to find the Cartesian product A cross A, it should have 36 ordered pairs. All right, my little epsilons, stay positive.